I titled this lecture, Creativity, Can Computers Cut It? And it sort of leaves the obvious question, cut what? I'm based in Norwich, of course, so cut the mustard, I think, would be the appropriate thing to say. Those of you who don't recognise this, this is the flag of Norfolk, ladies and gentlemen, which is mustard yellow on the left-hand side, to remind myself that mustard is inextricably linked with us Norfolk folk. Now, this lecture has a starting point of talking about creativity, and creativity is a very sort of problematic area, I think, particularly for computer scientists. Computer scientists are rather fond of reasonably precise definitions of things, and let me give you a quote. Edgar Dijkstra, who is one of the sort of nobility of computer science, said, asking if computers can think is about as sensible as asking whether submarines can swim. And I sort of feel the same thing about creativity. It's really not very well defined, even for humans, and it seems to cover a very wide range of activities, which range from the very, very mundane, indeed, to the quite extraordinarily sublime. And that's going to be a challenge. And we're obviously going to be talking about machines that are programmed by people to be creative. And there's this other sort of nasty business of where does creativity of the programmer end and where does the creativity of the machine begin? Well, I'll try and give some indications of that as we go through. I have nothing very intelligent to say about that, I should say. That's for you folks to think about. It's going to be quite acute, this issue, over the next few years. It's probably analogous to the question of where does life begin, which so exercises Americans when they're thinking about that issue. And, where does creativity begin? Always is a great problem. And I'm not even sure that there are certainly people who would claim that computational creativity cannot actually be really creativity in the sense that we might mean it in everyday conversation. Furthermore, I'm going to delineate creativity a little bit. And what I'm going to focus on in this lecture are those little blobs on the left-hand side of your slide, sort of what Victorians might have called the arts, I suppose, linguistic, visual and musical arts. The one that I'm very interested in is creativity and problem solving, finding new solutions to something. I have almost nothing to say about that. I think it's a most interesting area. I don't know of any. There are some minor. There is some minor progress in that regard. I can think of a few sort of basic problem-solving systems, but I'm not sure they solve things in a particularly creative way. So that big blue blob, very interesting area. I'm going to leave it for the time being. Partly because I don't want to give a lecture about philosophy. I don't know much about philosophy. And partly all the good examples are over in those other blobs. And that's what I want to talk about today. So let's start with linguistic arts. In the previous lecture, I spent some time looking at methods of doing text processing. And I don't want to repeat that material this time. And you don't need to have done the whole series to understand this lecture. So I'm going to gloss slightly lightly over some bits, and that's because if you are interested, you can just spool back and look at the previous lecture on text processing, which will talk about some of these activities. And the sort of modern triumphs that we're talking about really in the linguistic arts are all due to one bit of technology, which is the deep neural network. And I'll try and indicate where these take place. But just to give you a sort of sense of history, I think what I'll start with is computational humour. And there are conferences on computational humour. I have to admit, I've never been to one. I suspect that they might not be the biggest laugh that you've ever had in your life. And they have a sort of fairly noble history. People are working on computational humour for probably 30 years off and on. I've just picked two example systems which are relatively well known in the literature. Both of them focus on sort of stylized jokes, like riddles and puns. Okay? And the good thing about that from a computer science point of view is you can generate rules for generating riddles and puns. The first system was called JAPE, and its successor was known as StandUp. And so JAPE, are these riddles, questions to which you get surprising answers? What do you call a strange market? And then you're going to get the answer in a moment. And what do you call a washing machine with a September? So the idea is that these are more sophisticated versions of humour. Well, let me give you the answers and see if we get a huge belly laugh from the audience. I suspect not, but let's just give it a go. Okay, what do you call a strange market? A bizarre bazaar. What do you call a washing machine with a September? An automatic washer. I thought that last one was quite good. Now, of course, so both of these have been tested against humans to see how funny they are. You'd expect systematic scientific work in this area. And JAPE, I seem to remember, was tested. So the test was, did people find this more funny than text that was not designed to be funny? And the answer is, yes, they did. But was it as funny as jokes told by humans? No, it wasn't. Well, I think that's hardly a surprise, listening to that. StandUp, if I remember rightly, was a system that was designed to help, it possibly was designed to help cognitively impaired children who had some trouble processing jokes. So the advantage of these systems is they can tell joke after joke after joke after joke, and parents and carers eventually get sort of defeated by the boredom of having to tell the same joke again and again and again. So that's the sort of base level that we've got in a creative text. I'm calling it creative in the sense that these jokes are not fed to it. These are jokes that are created from rules. Both of them use a description of the English language called WordNet, which is some sort of semantic list of all the words in the English language. And they're able to look for patterns and generate jokes that people haven't seen before. It's rather primitive, and I think it's fair to say that in the early 2000s, certainly I, and perhaps quite a few other people, have reached a sort of a feeling of gentle despair about generating meaningful text. This rule-based approach really wasn't going to get anywhere. We can't design rules for every single bit of humour. It's sort of complete madness. Even stylized humour like Cooperisms. Do you know about Cooperism? Cooperisms are jokes of the type invented by Tommy Cooper. Like I went down the corner shop to buy some corners. They didn't have any. I went to the paper shop, it blown away. So they're sort of Cooperisms. They've got this surprising ending. They're now practiced by the great humorist Tim Vine, and they're slightly formulaic. So we reached a sort of state of grim despair, really, thinking, well, we won't really do very much. This rule-based thing doesn't work. And the machine learning techniques that we had really weren't very effective with text. Well, all of that changed with two technologies, one of which I talked about previously, which was a technology called word-to-vec, and that was a neat way of getting words into numbers. So as soon as you've got numbers, you can do some machine learning. And the other one was the idea of a recurrent neural network. That's where you feed the output back into the input, so you can get this infinite history of what's happened. That's important for text. The trouble with text is if you have a sliding window going over the text, you're obviously only looking at a few words, and really you want to have a sort of memory of what happened previously. So you can use those to analyse text, but you can also drive them backwards to create text. And they're now operational. So for example, let's pick an example. This is some work done by Automated Insights. Automated Insights are a commercial company who work with, amongst others, Associated Press. And you feed in numbers, in this case, sports game scores, and you generate stories. And so I'm sure you can guess which one. Well, let's just do a quick straw poll with the physical audience. I always wished I could do this with the electronic audience. I can't. So, physical audience, do you think the story on the left was computer generated or the story on the right was computer generated? So would you like to raise your hand if you think it was the story on the left that was computer generated? And the story on the right was computer generated. It's even Stevens, and some people don't really know. I'm surprised at that. Okay, it's the story on the left that's computer generated. Now, it's a bit strange to read, isn't it? Because firstly, it's about American football, and mostly the physical audience is a British audience, and generally we don't know anything about American football. And secondly, there is a particular way of writing American journalistic style which takes you a little bit of time to get your head around. American journalists are very fond of using these very sort of compound nouns, and they have also a very abbreviated journalistic style, which I find hard to read. But I'm assured by my American friends that this is perfectly reasonable text on the left. The one on the left is quite factual, I would say, and the one on right is written by a professional sports journalist of the same game. The one on the right has lots of commentary and drawing analogies, he's trying to draw out a story about some people failing by looking at several stories across a number of different news sources. And so that's a sort of typical human endeavour, isn't it? You know, making up a story on the basis of thin evidence. And what was interesting was that this paper down the bottom here actually asked people which one of these they preferred without telling them whether it was computer-generated or human-generated. And it was a bit of an even tie, but there was strong interest in the computer-generated version because it was so factual, and it didn't really layer another layer of explanation on it. It just wrote out the facts in a rather nice and neat way. Now, Automated Insights are not the only company doing this. There's a company called Narrative Science. They work with Forbes, and if you've ever read Forbes, they do these, it's a real nausea, this. If you're a financial journalist, you have to take all of the big companies' quarterly reports and write a little bit of text about them. God, it takes ages, you know. So it's now written automatically on the basis of the numbers. And there's a British company, I think, called Aria, which does the same thing. So the three zones where you might expect this to be used are weather. It will be cloudy tomorrow with upward temperatures of this and that. Sports and financial. Rather interesting area. And this stuff is with you now, okay? You have probably read already some computer-generated or automated-generated text. So at this point, what usually happens, particularly if you're at a literary university like mine, somebody will pop up and say, oh, no, well, yes, this is a very low level of creativity, very mundane, you know. When will anyone write a sonnet? Ha, 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 ha. You know, well, there we go, there's the sonnet. So this is from a paper called Shall I Compare Thee to a Machine-Written Sonnet? And I should explain how this is... now, I'll leave it... I am highly unpoetic and prosaic gentleman, so I'm not really in a position to tell you yet whether this is a good sonnet. But let me give you some information. The way this is usually assessed, and the way these systems are often assessed, is something called a Turing test. A Turing test is where we don't reveal whether the source of the information is a computer or a human. And if humans cannot tell the difference between the human-generated output and the automatic-generated output by some sort of vote, we assume that we have passed the Turing test. Okay? And Turing tests are they're quite controversial. I mean, people don't like them for various reasons. They raise a whole load of questions like, who should be in the jury? You know, should it be experts or non-experts? Interesting question when you're talking about creativity. And do we really have to have a vote on this? It's not very precise, is it? And how big should the vote be? And should there be a margin of, you know... Well, those of us who are living through public votes know all about the hassle of interpreting public votes. So slightly problematic. Nevertheless, there is a Turing test for sonnets, and it's called Poetics. I think it runs every year. And this system is the winner of Poetics 2018, and it uses the two standard technologies at the moment, which are word embeddings. So that's a neat way of getting words into collections of words, actually into a set of about 300 numbers, and then it uses a whole load of machine learning, and then you drive it backwards. So you put some noise into this thing, or you put a keyword. In this case, the test was given a word, a prompt. You had to write a sonnet, and of course there's a human having to do this as well, so you have to slow everything down, otherwise it's totally obvious that there's a human involved, because a human can't write sonnets as quickly as a computer. So you slow them all down, then you give them back to your expert panel, and the expert panel says, oh, I can't tell the difference. Now, I don't actually know, poetics isn't very clear on whether it was an expert or inexpert panel here. And they're also not clear on, okay, they won the test, but by how much? But my assumption would be, from what I've read about this, that there is a substantial number of humanity that would believe that this was an acceptable sonnet. Quick straw poll here. Who finds this an acceptable sonnet? Oh, none of you. One or two brave people are prepared to admit, I think it's okay. The only thing I would say, which is a bit of a fix if you read the paper, is the authors of the paper decided what the title should be after writing the sonnet. So I can't help feeling that the title sort of cues you up to give all sorts of hidden sort of semiotic and sort of secret meanings to the thing, which makes it seem very profound. Anyway, it passes the test. Now, I was sort of speculating as to how I could show you these models working in action. And I think the easiest way to do that is to take a really, really simple model, a model that actually isn't very good, and it's just based on 3 or 4 characters. And what you do is we're just going to chuck loads and loads of text at it of a particular type, and then we'll run it backwards and see what it generates. And you'll see that there are some parameters you can fiddle with, which are basically the adventurousness of the model. So if the model is very unadventurous, it tends to just repeat stuff that it's seen before. And if it's quite adventurous, then it has the capacity to make up stuff that it hasn't seen before. And I was thinking, oh, I better do this. And then I was delighted to discover that the New Yorker had done this already. So the New Yorker is, humorous magazine based in the USA, and the source text that they had picked for this was President Trump's speeches. So, well, what an excellent source that is. I find President Trump's speeches quite challenging linguistically anyway, so let's see how they did.
Thank you, all of you. They are donating to the problem. I don't want to do it. I don't know what they don't know, what they don't know. That the assumption that we don't know, that the best members of the prison, and there are supposed to be a lot of them, to be a little bit because I don't want it. I don't want to be a little bit this country. I mean, it was a nice person. We want to put the White House. I mean, when you get the hell of the bad guys is not going to be asking, do it for the world. We've got to the firewall. That's what they do. I mean, we have to do it for the country. I want to renegotiate NAFTA. And they say they are tired of the speech is a very international debate. And they were supposed to have such great buildings. They are going to let them something that we don't know the pressure that we will start winning again. I will uphold out every single conservative for the friends of the lay-being radical Islamic terrorism. When I see the money of the country that are tough and probably going to start a problem. It's not such a great state. And all of the places and the whole tax people, and we have no choice. It's a strength. You want to do the Raz's obligation with the special interest for discuss and the promate that reach the top people getting the smart immigrations? We will be in the time. I will say and change anything. I would have never had a victory. And we will build brutal energy cut into a much better home. It's a movement toward the beautiful legal scams and better share. And it was a jiggly deal, and I don't think they're never worth in the middle deal to be parted to Mexico. It's Tawali. I have a toupee. You don't even get 1.6 trillion dilation and millions of dollars. I mean, I end illegal immigrants. They're scared, I promise. In the prison way, our energy revolution plan for my friendlic and deportant. And you're not going to be disqualified. We have said that. I surprised it. She doesn't take to you, guy. Believe me. Now, hello. But I hear for I'm a king of terror that 20 years, but let prevent these vast learned people precrucity puri of the Bassett than Obama. I prick Wally through. It's last year, it should arguing the turnish. I am proposing remissation corruption. I am going to work with us. Every year, that Prep Agony has dive in a big lie. Thank you. Thank all of you.
I'd like to answer the last question. Yeah, there is a great big chain on YouTube where I found that video, which just does. Most people think that the increasingly demented version of level 5 sounds closest to Mr. Trump. So the point was, it's captured his speech patterns quite effectively, I would say, and I probably am heavily influenced by the brilliant imitation. And you can see that the difficulty with that particular system is it's only using quite a short window. So these spoof words like, what were they? Tawali, one of my favourite words. A jingly deal. I'm always wary of jingly deals myself, and I'm going to look out for them in future. Are possible. The systems we were looking at before that operate at a word level, so they're choosing words from a word net, so it stops them picking weird words. Okay, so that was a quick review of the state of the art in linguistic arts, and I'm not sure you were agreeing with me just looking at your faces, but I would say there's quite impressive performance there. There are restricted domains where it looks to me as though the computer is pretty much indistinguishable from a human. There are the full domain, we've got some way to go. So the computers have not yet written Harry Potter. They have written some novels. In the 1970s, there was a brief flurry of novel writing. They were all rule-based and terrible, terrible reads. I mean, you couldn't read them for very long. So now, visual arts. Well, visual arts is a nice illustration of the sort of state of technology. Visual arts, of course, map rather nicely onto machine learning systems. Machine learning systems are really designed to work with rectangular grids of numbers. So that's what a pixelated image creates. And I talked about this a few lectures ago, talking about computer vision, machines that see. And if we sort of spool back to probably 2000s again, we were into a position where computer scientists were building tools that were essentially controlled by digital artists, humans. So you would say, oh, that's an interesting effect. Yes, I think I can make something of that. And I did this. We ran a nice company that made converted images into painterly effects. They were quite common. There were some very bad ones. There was a very bad sort of pointillism effect, So that was trying to imitate the paintings of Seurat, and it was deeply unimpressive. We worked on something called the Sieve, which was a scale space processing system. I talked about it in previous lectures. And much to my surprise, I was watching a film called Wimbledon, which came out quite a few years ago. And somewhat to my surprise, very deep surprise, because they hadn't paid us any royalties, I saw the effect being used. So I'll just show you the sort of thing which you'll be quite familiar with. So this is the credits of this rather, what is now rather rare film, Wimbledon.
We all start off in life with a dream, don't we? For a tennis...
Fine. So, painterly effects used by a digital artist. In that case, I assume they were worried about the identity of the audience. They probably didn't have permission. So that was sort of phase one. And phase two, which I'm going to talk about now, is the business of trying to copy or replicate artists. And that's a very interesting area. Again, I think you would probably think the thing I was just talking about, the creativity there is really, it's mundane in the sense that, I hate to say that about my own work, but it was, although it was, the algorithms were terribly complicated, the thing that made good pictures wasn't the algorithms, it was the people putting them together. Okay, and I know this because we had a number of digital artists working for us, and the truth was that some were very much better than others. So option two, if you like, is, well, can we mix in equivalent effects from well-known artists? So, for example, if we took a photograph of my dog, Algernon, looking, I think, frankly surprised after he's had his hair cut, and you were a sort of admirer of, I don't know, Umberto Boccioni, the Italian futurist. This painting is called the Dynamism of the Cyclist. I think you can see the cyclist and you can see the sort of painterly effects. So what you would like to do is you'd like to take a photograph of Algernon as if Boccioni was in the room, and there you go, okay? So this is not too bad, is it? You can go to, what is it, InstaArt, I think. By the way, on the transcript, you'll find a list of all of these references, so you can chase them down if you want. You can go to InstaArt and you can, as I did, upload my photograph. And this is a bit of machine learning that has learnt how Boccioni painted, and it's created a rather attractive version. And there's a number of styles from which you can choose. So if you don't like Boccioni, I do, but if you don't like Boccioni, you choose Manet and you'll get a Manet. By the way, the last phase of InstaArt's business proposition is fascinating. I do recommend going to their website. They will actually paint it for you. So a real artist will take this and actually paint it for you in oils or pastels or gouache or whatever you choose, I think. And the way this is done is a village in China which appears to consist entirely of human artists painting things to order. I think I read 10,000 artists. It seems rather incredible, doesn't it? And they'll do it in a week. So there you go. If you ever need a quick retirement present, that's the solution. Now, how this works is a bit of a challenge, because I said something that was really, I skipped over it very lightly, but it's a real problem. learn the work of an artist. It's quite tricksome, because artists, even prolific artists, don't really produce enough art to learn. I mean, the sort of learning that we're used to doing is tens of thousands of millions of images. Well, there are not tens of thousands of Boccioni paintings. Maybe that's the basis of their rarity. So what can you do? So it's quite clever what people do. And I've tried to illustrate it here in this rather complicated diagram, which I'm going to talk you through. So what they did was this. They said, well, let's take one of the standard deep learning neural networks that recognize objects. Nothing to do with paintings. It was trained on an object database, I think. So what they made a list of objects that a 6-year-old might be able to name. And they took loads and loads of photographs of those things, and they slung them into their neural network and trained it to recognize those things. So yes, there is a car in that photograph. Yes, there's a bed. You know, those are the labels. And you whir around, as described in previous lectures, and you learn this thing. And the network they use, if you're interested, is one called VGG. You can download it yourself, download it and run it. It's just very easy to use and run. And then they said, right, okay. Well, the high level of this network is all semantic stuff to do with recognizing objects. But the low level is all to do with extracting features that might go into helping the recognition. So they said, well, let's feed our sort of target image over here through this thing over here, and we'll also feed our target painting. Is that Kandinsky? I should have... You think it's Van Gogh? Oh, it's Van Gogh, isn't it? Yeah, it's Van Gogh. And what we'll get out here are more and more object level stuff. And what we get down here is more sort of painterly texture level stuff. Likewise, down here we've got all the fine level detail, and up here we've got the coarse level detail. Well, that's not unreasonable given the way we do object recognition. Computer object recognition usually finds these, what they call feature interest points. You agglomerate these interest points and say, well, yeah, it looks like a house then. I've got enough of those features to be a house. Doesn't do it systematically by thinking about it. It's all done in the training. So then the next thing they did is, right, I'm going to create a random image here. Fill it with random noise. And now I'm going to develop a learning algorithm which adjusts that image such that it looks like it's painted by, in my case, Boccioni. So what I'm going to do is I'm going to demand that all of these low-level features, low-level stuff here, they have the same statistics as a Boccioni. And what I'm going to demand is up here, they have the same level of statistics as the object detector. So it's quite a complex bit of training, but that gets you round the business of having to learn stuff. What you're doing is you're adjusting the input until the output looks, the analysis bit looks sort of convincing. So really rather neat trick, and quite impressive, and I think it gives reasonable impressions. But I suspect there are still people in the audience who are sort of crossing their arms and saying, well, it's not really creativity, is it? Mimicry isn't creativity, it's just a neat trick. I mean, what we really want is some sort of artificial intelligence computer system that can generate a painting from scratch that was not in the minds of the human creator. And then we need concrete evidence that that painting is of value, and it's got some creative value. That would be the ultimate test, right? So the ultimate test would be build a computer system that can print out a painting, and we'll take it to Christie's and we'll flog it, and it makes some money. Okay, well, this is a painting called Portrait of Edmond Belamy. It was indeed sold at Christie's. The estimated price for this was $10,000. It actually made $425,000, and it's completely computer generated. It's the first of its kind. A very interesting system that creates it. It's created by a collective of Parisian artists who call themselves Obvious Art, and they have a couple of YouTube videos and quite a good website, which I recommend. The YouTube videos they are subtitled, but they're all French and they speak in French. But it's pretty obvious what they're saying, and very interesting. Now, I don't know, what do you think of this painting? I mean, I think it's rather... I come from the University of East Anglia, which has the Sainsbury Centre for Visual Art, and in there is an unrivaled collection of Francis Bacon paintings. And so I sort of find myself thinking, drawing comparisons with Bacon here. It looks a bit Baconish. And Bacons are incredibly valuable at the moment. Somebody estimated that we had enough Bacons to actually rebuild the whole university if we sold them, which, given the state of the buildings, is tempting. And there's a family of these that are being created by their neural network system. So the way they do it is something called a GAN, okay? A generative adversarial network. And here's a quote from one of the artists, stroke business people, stroke computer scientists who created this. I'll just pick out a couple of things. He says, we feed the system with a data set of 15,000 portraits painted between the 14th century and the 20th. I have a suspicion that 15,000 isn't quite enough. So I'll hazard a guess that they also fed it with something else. By the way, this is probably a good point to point out that an awful lot of this work, it takes place in the commercial sector. And it is not very obvious sometimes precisely how these systems work. I'm often having to infer from pretty scant literature what they probably did in order to do this. So what my thinking at the moment is that I would like to demonstrate as much as I can take the state of the art to you, but the state of the art is mostly in the commercial sector. So I'm having to make some guesses as to precisely how these systems work on the basis of what I know the state of the art to be in the literature. So there's just a slight caveat on some of my facts there. The generator makes a new image, and the discriminator tries to spot the difference between a human-made image and the one created by the generator. The aim is to fool the discriminator and think the new images are real-life portraits. Then we have a result. Okay, so it looks like this. That would be a typical GAN. And, well, Yann LeCun, who's one of the great fathers of deep learning, is saying great things about it, so he knows what he's talking about, so it's probably impressive. So the idea is this, which is we will have this great big set of real data here, and this is a network that's designed to tell whether the thing here is real or not. So it learns what real is, and it says, is this real or fake? That's that thing there. And then what we're doing here is we're making up images. We start with some noise. This is another neural network, right, that's being trained to produce these things. Okay, so you train this one and this one simultaneously. So obviously what first happens is this is untrained. It produces complete rubbish here. This thing has an incredibly easy job and goes, rubbish. And then we feed back, and we do that, a couple of million times. It takes, I should imagine, 3 or 4 weeks of continuous processing using the biggest and most powerful CPUs you can gather. And there comes a point when this thing generates something that fools the discriminator. At that point, you've got art. It was random noise in, it was a painting that came out, right? So that's my definition of artists, by the way. Artists are people who take random noise in and they produce art at the output. If you can't tell it apart from the other genre, then I decree it to be art. Okay, so none of Marcel Duchamp and all that stuff I put to one side. I don't do conceptual art here. We're doing figurative art. And there's the result. And, do have a look at their website. These GANs, generative adversarial networks, they are hot stuff. And probably the sort of benchmark example of a GAN is generating photorealistic human faces. So a lot of this work has been done by a company called NVIDIA. NVIDIA used to make graphics cards for computers, and that's what they're set up to do. It turned out that these new deep learning systems have incredibly difficult computational demands, and with a little bit of software engineering, you can re-engineer them to run on these graphics cards, which were very efficient at doing these multiply accumulates. So the early deep learning networks that you could all download ran on NVIDIA cards. So very rapidly, NVIDIA became a artificial intelligence company because they were selling far more of these graphics. They didn't realise it at first. They think, that's very weird. We used to only sell them to odd gamers, stuck in darkened rooms, delivered to small garrets in places. And suddenly we're selling 1,000 of these things to great big government labs. What the hell's going on? Well, they were being used for AI, and now they work in that area themselves. So what I'm going to show you is a video of human face generation. I think it's got some subtitles so you can work out what's going on. But let me just emphasize one point, which is said in the video. You are not going to look in this video at a single real human face. Okay? Every single face you're looking at in this video is made up by a GAN. Impressed with that? Yeah, it's cool, isn't it? Slightly creepy. So the next time you see a photograph, it might not be quite what you think. There is a stunt, by the way. There is a trick for spotting synthetic humans, which I'm afraid time is pressing, so I can't tell you what it is. But it is there is a well-known artifact that allows you to spot a synthetic human, but it will soon be fixed. Okay, so I want to briefly talk about music now and music composition. The benchmark system for doing this is Iamus, which is a compositional cluster based at the University of Malaga. It has a commercial variant called Belamy, and that has made it a little bit tricky actually to work out quite what Iamus does because it's all shrouded in commercial secrecy. What I can tell you is that the first Iamus album has been recorded. It was recorded, so Iamus writes the score, and the London Symphony Orchestra were involved in recording it, and you can go out and buy the album. It's quite avant-garde, so my rather bourgeois taste doesn't really appeal to me at all. But Melomix is designed to appeal to people like me. I was playing it to our sound crew at the back, who said, "Oh, yeah, it sounds just like computer-generated music to me." Well, you can have a quick listen. Yeah, it's a bit Californian, but I'm not entirely sure that I would spot that immediately as a human. A lot of these music systems rely on something called a genetic algorithm. And I just thought I'd take a brief moment to explain how that works. It's quite fun. It's a model of the way animal genetic selection works. So the first thing you do is you decide on a mapping between your score, or bit of your score, to some big, long binary number, usually. So there's a bit of art in doing that. But the idea is that there's going to be a unique map between the score and this long binary number. So, for example, you might say, the time signature is mapped to this bit of the code here, and then the first bar is mapped to this code, and so on and so on and so on. And that forms a population. So you might have thousands of those, tens of thousands of those, and they're all rubbish because you initialize them randomly. So they all sound like complete garbage were you to play them out. But that's the population of compositions. They're just big random numbers. The next thing you work on is a fitness function. And the fitness function says, this sounds good, this sounds not so good. It doesn't have to be fantastic, but it just needs to be something that says, if you give me a binary number, I can convert that into a score, and I can give a score as to whether I think that is good music. Okay, so it's a bit like a compositional aesthetic. The next thing we're going to do is we are going to, just ignore this for the time being, what we're going to do here is we're going to, in this box, we've still got a population of compositions, but I'm now going to select the fittest of those. So I'm going to say, those compositions, they're too poor, kill them, get rid of them. Okay, so that's survival of the fittest at this point here. And then this is mutation, where we breed some of these together and produce a new set, and we evaluate the fitness and so on. And we just do that million billion times using great big computer cluster. And at some point, you listen to the best composition, and the human goes, oh, I like that one. Stop. Job done. Now, is that where the creativity is? Because there is creativity in working out this mapping. There's no creativity here in sort of humdrum terms. It's just hammering around an optimization loop. Genetic algorithms are very commonly used for difficult optimization problems. There's tremendous creativity in thinking about the fitness function. And if you read the references on Iamus, you can see that the guy who developed it is a professional composer and pianist, and he has I would say, a very well-developed sense of what he likes in music. And he's done his best to put that into the fitness function. Okay, so that's the state of the art in composition. Now, just for a bit of fun, I mean, I should say, we're only talking about music there. You can actually, what about words? Well, you can go back, we can scroll back and use the same technology I was using for words, of course, and create some lyrics, if you like. This isn't quite the same level as creativity as Iamus. I mean, Iamus is sort of the pinnacle of musical achievement. But if you fancy a bit of lyrics, let's just take, say, hotel and restaurant reviews from Yelp. Yelp is a big American site. Americans are very free in giving their opinions on everything. A very highly service-orientated culture. So I don't know about you. I never write honest reviews on Yelp. I always worry that someone might come and pee in my soup. So I always very guarded. But they're not. They write extremely positive or negative things. And so we can feed all of that into one of our generators, and we can generate a nice little tune. And thank you to James Bull, who's the technical director here, for pointing this out.
I ain't sure if anyone would think this place is good. Definitely won't be coming back. Very disappointed with the quality of food, and I was very disappointed with the staff.
I ordered shots of freedom and I ordered shots of wine. Seems like they were out of all of that. Honestly, I didn't care for such a tiny room. The manager was really, really bad. If you want to travel underneath the worst bar in the West, knock on this establishment again. It ain't no place to sit in and there wasn't enough bread. Not impressed, I would not recommend.
It's really rather appealing, isn't it? Okay, this is just a bit of fun. Now, one final observation. Most popular record companies have a division called the A&R division, Artist and Recording Division. They're enormously powerful, and they look for hits. Could you automate that process? Asked Music X-Ray, who are a company that did this. This is Ben Novak. Ben Novak wrote a song called Turn Your Car Around, which was later recorded by Lee Ryan from Blue, if you are familiar with that. And it was a top 20 hit. As a result of this, it was brought to his attention by Music X-Ray, and Sony Records took it on and promoted it. It's really, and it relies on the fact that a lot of pop music is somewhat formulaic. I'm not sure I've got time to play this to you, but let's do.
It's all about us. Can you hear it again and just take it on trust? Yeah, you still got a way to get out of this one-story town. So you swallow your pride when you're filling the gas, and you're laughing inside about kicking your ass, and you gotta stand up. If you don't, then you're just falling down. So why don't you turn your car around, forget your way back home?
Quite catchy, I would say, and I think one of the first songs to have been spotted as a hit by a computer. So where does this leave artists? Well, there's obviously good reason to have some panic, because some of the standard artistic practices are being automated. And I quite like this quote, which is sort of really rather establishes the anxiety that's present in current artists with computational creativity. Perhaps I should reveal that it dates from 1850, from the painter Eugène Delacroix. So this is obviously an old concern. And then I probably should also pivot us a bit into thinking about where this automated production of art and journalism might take us. This is a quote from 1984 by George Orwell, who developed a machine called the versificator. And versificator produces rubbishy newspapers containing almost nothing except sport, crime, astrology, sensational 5-cent novelettes, films oozing with sex, and sentimental songs, which are composed entirely by mechanical means. Well, I've certainly covered some of those, ladies and gentlemen, during the course of this lecture. So we could indeed be entering a new generation of tat using some of this. And it neatly pivots me into an issue that I am quite interested in. In this season, we've been talking about how information science leads to new developments, but I haven't been talking about the impact of that on the digital state. And that is what I would like to do in the next series of lectures. We're going to talk about biometrics and social media and digital learning and digital healthcare and digital crime and the cashless society. So if I can briefly encourage you to make a date for late October, which is when we start the series again, that would be very welcome. Other than that, thank you very much.